Okay, so now we're going to try and start to describe some of the things we see in the rocks. So some of the different grain types. Remember we said for siliciclastics, for the most part, we were looking at quartz grains, some minor amounts of feldspar and other trace elements. Here we're looking at something that's all basically the same mineralogy, either calcite or possibly some dolomite, but we're looking at the actual grains themselves. So the first group we're going to talk about are what's called non-skeletal grains. So non-skeletal grains will be, just as its name implies, anything that doesn't have a hard skeleton around it, but there are class and different pieces, different types of grains that occur in carbonates that aren't really skeletal at all. So the first one would be peloids, also maybe called pellets. This is fecal material. So this is material where the organism is living on the seafloor. It is incorporating sediment, so it takes in the sediment, it ingests the sediment, so it eats the sediment. Its body uses the organic material in the sediment, but then it passes the sediment out through its gut and anus, and you end up with a series of little small pellets commonly composed of micrite. Okay, so this is small little pellets of micrite, and they can actually accumulate and make deposits that you would call them made up of nothing but pellets. Okay, so pellets or peloids is the first type. The next one would be ooids. Ooids are rounded grains. Commonly they have a nucleus and they grow through chemical processes around the outside. And they range in size from 1 to maybe 2 millimeters, generally no bigger than 2 millimeters. And they commonly have a smooth surface, and they may, in some cases, look like they have growth that's radial or tangential. Okay, especially if you go put them under a thin section and rotate the stage, sometimes they'll be this tangential, but then other times they'll be radial. So different types of ooids can form from both aragonite, high mag calcite, or calcite itself. The next one, if we think of ooids as sort of 1 to 2 millimeters, the next one would be pisolites. These commonly are larger. They obviously generally have a nucleus too. They can be more asymmetric, but they're bigger. They can be up to 10 centimeters approximately in size. So these are much, much larger structures. Okay. We're going to see that you can also form these through soils. There are things called soil pisolites. In that case, what you would see is commonly they form with a nucleus. They start to form, and as the roots move through the soil, grow and move these things around. They'll commonly grow asymmetrically and be thicker on the downward side because they're forming as the waters move through here and precipitate out the calcium carbonate. They form more on the downhill side than they do on the uphill side. So those are pisolites. We also have something we call oncolites. They also look similar, except for now these are formed by microbes, algae, bacteria, things around the outside. They're commonly more irregular. The laminations are very irregular, and you can tell that they're algal if you've got a thin section. So those would be oncolites. So ooids, pisolites, and oncolites are very similar in that they all generally have sort of this rounded structure, but ooids are generally the smallest. Commonly you'll find that they'll be well sorted. Pisolites get bigger, formed by different processes, evaporation, things rolling around. And then the oncolites are formed by algal growth around some sort of a nucleus. And their size can also vary quite a bit. And usually you will know them because they're going to have these very irregular textures, whereas the pisolites and the ooids are generally fairly smooth growth. Okay, so we have pellets, ooids, pisolites, and oncolites. And then we have some of the things that we see. We have what we call intraclasts. If you can imagine a tidal flat, where the water is not very deep. We deposit some mud and then some carbonate silt over it. A storm comes through and rips that up and redeposits in the same area. That would be an intraclast. So generally in situ. Okay, we also have things that we call lithoclasts. These are much harder to tell apart, but commonly when you're looking at a lithoclast, you're looking at a rock that has a much older age in a much younger rock. And so the example I like to give is when you're at field camp, you're going to be looking at a rock that's made up of a whole bunch of clasts of Cambrian, or mainly Devonian through Mississippian carbonates, but the rock itself formed during the Cretaceous. So what happened was these rocks were deposited as flat-lying sediments. There was a mountain building event which squished them, folded them, contorted them, uplifted them. Then those carbonates were eroded, and as the clasts moved downhill in alluvial fans, they made these big conglomerates. So those clasts, because they're much, much older, they're what we would call lithoclasts. Now you may see your book use the term extraclast. We're not going to use that per se, but just the same thing. Okay? Carbonate people generally call them lithoclasts. The only way to tell this apart is with fossils, or some way to tell the age. Okay? We know that these clasts are carbonate, and they're from a different time than when they actually formed. So these are the main types of non-skeletal grains. We'll talk briefly later about some of the skeletal grains, but you're just going to have to go back through your historical notes and try and figure out what are some of the different shells, and I'll try and tell you what they are, but then you're going to have to get at some of the characteristics, and I'll give you a brief summary of some of those, but I'm not going to spend all the time. Okay?